You're watching the Discovery Channel. Next up, the Mathbusters. Who are the Mathbusters? They're Adam Savage and Jamie Heineman. Between them, over 30 years of advanced math experience. They don't just tell the myths, they put them to the test. It's Mathbusters!
Welcome to Mathbusters, the show where we bust myths using math. I'm Jamie.
I'm Adam.
We have a great show for you today. It's our fan favorite show, which means you, the fan, get to pick which myths we bust.
And let's see what we got today. Look, Jamie, a letter. And it's from Johnny from Oklahoma. Let's see what Johnny wants us to do today.
Dear Mathbuster guys, I live in Oklahoma, and there are a bunch of cowboys where I live. They always wear these 10-gallon hats, but are they really 10 gallons? Love, Johnny.
Thank you, Johnny. That's a great question. And we're going to solve that. So, Jamie, how should we approach this myth? Personally, I don't really know much about 10-gallon hats.
Well, 10-gallon hats aren't my hat of choice, but I'm actually a pretty big fan of westerns.
You see, we don't quite know where the term 10-gallon hat came from. What we do know is that it just refers to a standard cowboy hat. Ranchers and farmers have been wearing hats in the West for a long time. But the first official cowboy hat was invented by John Batterson Stetson in 1865. The popularized version of the cowboy hat came from all the country westerns that were produced in Hollywood in the 1950s, 60s, and 70s.
So I think it's time to go to the Mathbusters Math Lab.
Let's go. So here we are in the Mathbusters Math Lab. Jamie, how are we going to solve this problem?
Okay, so here we have an approximate diagram of what a 10-gallon hat looks like. We have the brim of the hat right here, and then this part right here is the part we're actually going to find the volume of. And the best way to describe the shape would probably be a cylinder with a hemisphere on top of that cylinder. The height of the cylinder is 4.25 centimeters, while the radius of this cylinder is going to be 9.3 centimeters. And then the hemisphere on top of this is just going to be the radius of 9.3, like that.
So to solve this problem, we're going to have to use triple integration to find the volume of the cylinder and the hemisphere. We find those individual volumes, add them together, and that's going to give us the total volume of our 10-gallon hat.
Sounds good. Let's get to work. Nice work, Adam. So what's going on over here?
Well, to find the volume of the cylinder, which we're doing that first, we got to find the triple integration of 1 dz dy dx. Basically, 1 is easy, but you got to find the bounds. That's the hard part. So first you got to find the dz bound, which is 0 to 4.25, which is the height of the cylinder. Then you got to find your dy bound, which is you're going to use the equation of a circle as the base. X squared plus y squared equals r squared. R being radius 9.3, we square that, get 86.49. And then in terms of y, it's going to be root 86.49 minus x squared to negative root 86.49 minus x squared. Finally, we got the dx bound, which we're just going to use the radius of negative 9.3 to 9.3. Doing all the triple integration, you come up with your final answer, 1,154 centimeters cubed.
Great, so that's the cylinder. So the next part, obviously, will be to find the volume of the hemisphere, right? So this is the volume of the hemisphere.
Yep. So to find this, pretty similar process to the cylinder. So use the equation volume equals triple integral of 1 dz dy dx. Bounds a little bit different. X is the same, negative 9.3 to 9.3. Y is the same, negative root 86.49 minus x squared to root 86.49 minus x squared. Only real difference is the z bound. Since this is a hemisphere, we're going to be using the equation of a sphere, which is r squared equals x squared plus y squared plus z squared. So plugging in 9.3 for radius, and then isolating the z variable, we're going to get z to be from 0 to root 86.49 minus x squared minus y squared. Now the bottom is 0 because this is a hemisphere, so you're only going to be using half of the height. So doing all this complicated math, and some of this can get really intense. I actually had to use some advanced technologies to find some of these integrations. But your final answer becomes 1,685 centimeters cubed.
Okay, so if we add what we got for the volume of the cylinder, which is 1,154 centimeters cubed, we get a total volume of our 10-gallon hat to be 2839 centimeters cubed. And if you convert that in terms of gallons and quarts, you'll find that it's only about 3 quarts. Last time I checked, a 10-gallon hat would have almost 40 quarts.
Which means that the volume of our 10-gallon hat, 3 quarts, is actually 1/14 of 10 gallons. Which means this myth is busted.